Today we are going to talk about solving equations using our double angle identities along with the unit circle and all those techniques that come from being able to do trig functions using that angle measurements, angle measurements. Okay, we're going to break this down into 4 basic steps. Okay, number 1. Every time in these equations, and I'm going to do 2 of these today, we are going to see a double angle identity. You can see those kind of pop up all over the place. One of the things I'm going to do, if it makes sense, and most of the time it will, is to switch out the double angle identity with the functions itself, right? We don't really know how to work with double angle identities when solving, or at least if I had just a traditional x, it's going to make my life a lot easier. So number 1, I'm going to swap it out with its double angle identity formula. So if you don't have these memorized, which is fine, make sure you pull up your formula sheet and double check that you can see how to do this. All right, so we're going to switch this out with 2 sine x cosine x equals sine x. Now the only thing I did was I swapped out the sine of 2x with its angle, with its formula. Okay, step 2 is to get everything on one side of the equation. So in this case, I'm going to subtract the sine x right here to get it onto this side. And so we're going to say 2 sine x cosine x minus sine x, which is equal to 0. Now, step 3 is very temperamental. It will not be the same every time. What we're going to have to look at is the fact here that I have 2 terms, right? With 2 terms, step 3 is going to look more like a GCF. Be careful. It's not always this way. In number 14 in a minute, you'll see another version of this. These are the 2 main types we'll see. When I switch these out, I'm either going to have 2 terms or 3 terms. When you have 2 terms, we're going to talk about how we can kind of look at the problem and find the GCF. In this case, it's a relatively easy GCF. We know that we have sine x in both pieces. So we're going to factor out a sine x. That's going to leave me with a 2 times the cosine x minus 1. Be careful. Whenever you do this, you always want to take a second and distribute this back and double check you get what you started with, right? Sine times 2 cosine gives me 2 sine cosine. And then sine times -1 should give you negative sine. Check. That's not difficult, and it doesn't take very long. But it will save you a tremendous amount of careless mistakes. Okay. Step 4. This one is probably the longest piece. This is kind of going to take me from where I am all the way to the end. Here we're going to look, and we're going to find all of the factors that we have being multiplied together. In this case, you have 2 factors. We have number 1, the sine x. And then we have the 2 cosine x minus 1. We're going to set every factor equal to 0. 2 cosine x minus 1 equals 0. The thing we know about when we multiply 2 things together to get 0 is that one or both of them have to be equal to 0. And so at this point, step 4, you're going to be using your unit circle. If you've got your left-hand technique down, if you've got just the triangle method, any of those methods will get you to the correct answer. And so we're going to kind of set it up this way. The question is, the first one is really simple. It doesn't require any extra work. Sine, remember, on the unit circle is equal to the y-coordinate. Well, where is the y-coordinate equal to 0? If I draw these in, 1, 0 and -1, 0, will be the 2 locations on the unit circle where y is equal to 0. This happens to be at 0 and 180 degrees. And those would be the answers here. Now, there is a way that we can work this out using our calculator. If I were to say sine inverse of 0, it's going to give me 0 degrees. Notice, if you try this in your calculator, only one of the 2 answers show up. And so that's your caution. If I try and kind of bank on the fact that I'm going to always use my calculator here, I can guarantee myself that I'll get one of the solutions, but not both. Sometimes there is only one solution, so you're good to go in that case. But here, I'm going to make sure to actually work this out, double check myself, make sure I've got those things down, and make sure that I'm not just relying on the calculator. Okay, step the second equation, it's going to be, we're going to subtract or add the 1 to both sides and divide by 2. So we're going to end up with cosine x equals positive 1/2. This is more of a traditional kind of question. Cosine is positive, right? Remember, we have all students take classes. Where is cosine positive? It's in all, right? And then C. So this is really, your cosine is a 1 over 2. That becomes a square root here. This is a negative, square root of 3 here, and a 2 down there. And so the question is, what angle are we looking at here? And so we say that this is a 60-degree angle, top and bottom. So the answer would be essentially 60 degrees. Let me rewrite that. We would say x equals 60, and, well, what's 60 degrees below the x-axis? This would be negative 60, or you could say, really what we're looking at is the angle all the way around here. That would be 300 degrees. 360 minus 60. And so you have 4 solutions for this problem, and that is common. For every part we have, every factor we have, we had 1, 2 factors that we're solving for. It's common to have 1 or 2 solutions for the most options for these kinds of problems. Okay, that's one method. Let me kind of walk you through the second one. Cosine of 2x, this poses a second kind of process to this problem. If you pull up the identities for this angle, you know, or for this formula, you know there are 3 different formulas you get to pick from. Here's my tip. If I have cosine of 2x in the equation, I'm going to look at the other parts of my equation. If I have a sine or a cosine, which is probably common, I'm going to try to pick the correct formula that's going to keep all of the trig functions the same. So if it's cosine, I want to pick the cosine of 2x formula with only cosine. If it's sine, pick the one with only sine. Now, that's just going to make your job a lot easier. I don't have to work as hard, right? So step 1 is replacing that. We're going to use 2 cosine squared x minus 1 equals cosine x. Step 2 would be to get everything on one side of the equation. So we're going to have 2 cosine squared x minus 1 minus cosine x equals 0. Now, when you have 3 terms, right? 3 terms, what I really would like to do here is I'm going to write this in descending order of exponents, right? So 2 cosine squared x minus cosine minus the, if I can write, minus the cosine minus 1 equals 0. Okay, and so at this point, I have it in the right form. Step 3, remember step 3 is that tricky stage where I have to be careful about what it is I'm looking for, right? I have 3 terms, 1, 2, 3. When you have 3 terms, you are going to factor in a traditional sense. There's a lot of different names for different methods of factoring. Some people use the X method or whatever, but I'm not going to talk about any particular method. We're just going to do the factoring because this is not that tricky. Okay? We're going to essentially draw out our parentheses. We know we're going to get 2 binomials. And what I really kind of look at, I'm going to look at the first term. How can I come up with 2 ideas that multiply together to get 2 cosine squared x? Well, the number 2 doesn't have a whole lot of factors, right? It's 2 and 1. Well, how can I get cosine squared? Cosine times cosine. I'm also going to look at the third term, right? Negative 1. What multiplies to get negative 1? Here again, not a lot of options. In this case, we have cosine, 2 cosine and a 1, a cosine and a 1. Okay, third step. I look here at the third term and I look at its sign. If this number is negative, that means one of these is positive and one of these is negative. We're not sure which one, but it's real easy to check. Okay, what I want to do is I want to multiply the outer and inner terms, and I want to make sure that I'm going to get this thing in the middle. So how that looks like is we multiply 2 cosine times 1. I'm going to get, well, let me try this, plus and minus. I think that's the way it goes. Right? I'm going to try it. If it's right, great. If it's wrong, if I get the opposite sign, I'm just going to swap those signs and I'm going to move on. So 2 cosine x. And then if I do the inner terms, if I do the 1 times here, oops, I got to go back and fix that. That's a negative 2 because I multiplied by negative 1. But the inner term, when I multiply this together, I'm going to get a positive cosine. So cosine x here, so 1, a positive 1. When you add these together, I'm going to get negative cosine x, right? And that's what I wanted to make sure, is this the same as what I had above? And you can see up here that it is. If you get the same pieces together, guaranteed that this is the right way to do this, and now we can move on to solving the last part of the equation. Okay, and so what we're going to do next is we're going to take each of these pieces, right? We're going to say, we're going to do 2 cosine x plus 1 equals 0, and then we're going to do cosine minus 1 equals 0. Now, so this is essentially step 4. To factor it into its correct position was step 3. Step 4 is to take each of these factors and to solve them. All right, this is a lot like last time. We're going to subtract the 1 and divide by 2 for this side. And we're going to say cosine x would equal negative 1/2. On the other side, easier, so it's just cosine x equals positive 1. I can work this out. Cosine of negative 1/2, right, if I'm looking at that in the unit circle. Cosine, remember, it's all students take classes. Cosine is negative in the second and the third quadrants. We know that you're going to get a 1 over a 2. In this case, that makes the opposite side the root 3. That means that you're going to get a 60-degree reference angle out here. Okay, it's kind of small to read. But essentially what that's going to end up giving me is 120 in the second quadrant, and then 240 degrees in the third quadrant. Cosine x equals a positive 1, so where's x equal to 1? This actually occurs only in one place on the whole unit circle. It's just there, right? So we have a 0-degree answer on this section. Okay, so we end up with 3 solutions for this one. You're not always going to get 2 answers. Sometimes it's just 1, and that's okay. This is how you solve these. You're going to need a good amount of practice for this. This is something that does not come directly. It's not super simple. It requires you to remember a lot of things, especially like from the unit circle. It expects me to go back and learn GCF and factoring. It pulls a lot of the elements that we've spent time over, not even in this class in case, right? We really haven't studied GCF and factoring as much, but that's something that you're expected to know. So take some time, a lot of practice on this. This, I would assume, is the hardest part of the test. So give this your best effort, put your best foot forward here, and we can get ready for the test next week on Friday, and you can really try to make sense of this. If you can do well in this, I think you're going to do well in the test. So kind of take a minute, practice this. You get a question, let me know, and I'll respond as soon as I can. Thanks.